Evening from Nigeria. I'm Dr. Olebara Comfort. I am here to present on AI blending for smarter systems. And by this, I'll permit me to share my screen so we can look at it together. By AI blending for smarter systems, we're looking at how AI resources can be put together to have better delivery of smart systems. By smart systems, we're looking at IoT and how analytics can be carried out on IoT streamed data and use this data to gain insights into a particular scenario and make decisions based on the insight gained. Artificial intelligence is the branch of computer science that emphasizes development of human intelligence into machines such that the machines would think and work like humans. And this is actually made possible by data. Data is the life wire of AI. It feeds on data, uses the data that has been received to better organize whatever area it is applied to. Subsets of AI, we have machine learning, the neural network, the deep learning, the robotics, computer vision, and so many, and so on. So we have workloads of AI as machine learning, which is applied to anomaly detection and analytics, the computer vision, which is used in the interpretation of visual inputs, say from cameras and so on. The natural language processing, which has to do with understanding spoken words through maybe passing and syntactic processing, and then being able to use understanding to respond effectively and at least to a very high degree of accuracy. Then also be able to transcribe spoken words. Conversational AI, which has to do with engaging in dialogue and conversations such as chatbots, which can represent humans in, say, the human resource environments. Combination of these AI workloads can be used in a particular solution to get a better delivery of that system. Smart systems are devices that combine data processing, multitasking, or sensing, actuation, and communication. And when we talk about sensing, the ability of these devices to detect changes in their immediate environment, communicate these changes, be able to act on the changes, and that's what makes them, and then being able to also interconnect with other systems in the internet makes them smart. Okay, we have the smart cities, we have the smart grids, smart transportation, and so many others. Now in the cloud, this is the environment where all this take place. We have the compute, the storage, and the network, which kind of generally describes the as a service provisions that are available to enterprises and individuals seeking these resources. Now, IoT devices such as these smart bulbs, these routers, the refrigerators, and so on, get connected to the cloud through the internet IoT hub. A hub is actually a cloud-based connector of devices, which also is able to route in telemetry that has been received to, say, blob storages, and also be able to send them to functions for further analysis. Okay, this is how telemetry is routed, moves from the IoT hub, IoT device here to the IoT hub, and further to a routing system. Now, the inbuilt endpoint is the default storage of the IoT hub, and message, that's the first port of call for messages. And then message can be routed to the storage blob and other points also. Now, stream processing has to do with processing streamed data from the IoT devices. And the essence of sending data is not only for storage, but to be able to carry out various analytic activities on the data, which will help the enterprises gain insight into how the data can be used to better to improve performance of their system. Okay, for stream processing, we have a resource called Stream Analytics, which is used for analysis. And the Stream Analytics uses ingest, analyze, and deliver as components for this delivery. Okay, the ingest level is about the input sources. And these input sources could be the internet device, could be the logs and files from your system, maybe CSV files from network monitoring, and so on. Then it could be customer data, financial transactions, live weather streaming. Could also be business applications, various business applications that have been streamed. Okay, now the stream data must go through a hub or a storage blob that has been created under a storage account, okay, in order to be saved in the cloud. We have also here the analysis stage where SQL query language is used to query the streamed data, and their functions can be created, like user-defined functions can be created and integrated into the SQL environment for the querying. Delivery has to do with the output. Whatever has been processed has to be stored somewhere or has to be sent further for more processing. So that's where the delivery comes in. Like in the first instance here, we have the event hub, the service hub, and the functions. The functions can be used, like I said, to query the stream data. Also here we have the Power BI, which is used for visualization and insight gaining into the data. These are links that permit me to go on with the demo. Okay, for this demonstration, I'll be using the Azure Microsoft environment, and this environment enables me carry out the activities that have been specified. So to start, sorry, you have to have a subscription. Right now I have a subscription right here, and my subscription is a paid subscription. Okay, so I'll have to get a resource group and add resources that I acquire or I access to the resource group. So I have to name this resource group. I'm trying to work on temperature data. I name it temperature data 12 dash RG. RG shows it is sorry, create. I need to create one. I don't have one that name. So, and anyone you want to create has to be created under the subscription. So we have temperature, temp, data 123 dash RG. Okay, so now I need to give a region for this resource group, and the region has to do with data centers, and each data center, whenever you're assessing a data center, is advised you assess one that is closest to you. So for now, I'm assessing data center that is in South Africa because I'm in Nigeria and that's the closest to me. Okay, so review and create. Okay, done. So let's look for this resource group that has just been created. Same that I want to drop in. Now I need to have a hub to which my devices will connect. So I'm getting IoT hub and creating one. Okay, so I need to select the resource group I just created, the term data 1 to 3, and I need to give a name to the hub, term hub 1 to 3, and then the region is selected also as South African North. Now, for the hub, I need to know the management levels I have. I'm using the standard tier, which offers me 4,000 messages per day, but I'm charged $25 per month. So we have the basic tier 1, which can charge $10 per month, but offers also the same thing, but some resources cannot be accessed using the basic tier. So that's it. I'm using the standard tier so I can access many resources. So now I review and create the hub. Okay, reviewed, now create. After creating the hub, I need to now attach a virtual device to the hub, and the virtual device will enable me connect a physical device to the hub. Okay, so I'll quickly, let me allow this deploy, then so while this is going on, I'll create an instance of this in another page to help me create a storage account. Okay. Storage accounts are the accounts that allow you have a block storage. So you create an account, you create a container in the account so that you can save your contents to this account. So I'm going to look for storage. Storage accounts, create one. And I'm going to have it created inside the same resource group. Okay, so I need to choose resource group temp data 1 to 3 RG, scroll down, give it a name. Let me call this temp store. One, two, three. Okay. Temp store 1, 2, 3. Temp store 1, 2, 3. Okay, this is allowed. This is allowed. Okay, so still give a region for this new storage accounts. Give a name for this storage account and then create it. I need to have a container inside my storage account. Okay. So let's go back to the hub and still in process of deploying the hub. Okay, storage account has been created, has been validated. Now create it. Deployment is in process. Okay. All right, so we hold on and get this completed. All right, this is our storage account. So we just go to resource and now create a container inside the storage account. Scroll down and that's the container. Give the container a name. It requests the name it. So we call it temp container 123. Temperature container 123 and say create. Done. Okay, so we have our storage ready for this. Excuse me. And the next thing we'll do is to still check on our hub. Deployment is complete. So we need to create the device right now. Create the device. Okay, so temp for 123. I think I have two of the temp of 123. Go to home. Temp for 123. Use another hub. Okay. So let's select this hub. Select this device. Oh. IoT Hub and these are updating this system to ensure your device can continue video for details. Okay. There is. Okay, so let's refresh the page. Okay. Meanwhile, I've created my container and waiting for this page to be ready. Okay. Okay, so now we can create our device. It's up and running again. I want to give the Raspberry Pi as my device name. Dash Pi. That's the device name I'm using now. So let's save this. Now to connect my external device, I have this Raspberry Pi device. I have the device ID, primary key ID, secondary key ID, primary connection string, and that's actually what I need to connect to an external, the Raspberry Pi device. So I have that. I've copied it. Next will be to attach it to an external device. So in this demonstration, we are using the Raspberry Pi as online simulator, and we're using that to represent an IoT device because it's a sensor that can actually sense temperature data, humidity, and then send telemetry of the data to the cloud. So we are using this to represent we can do with this, we can do with any other external device. Okay, so on line 15, we have the connection string. So we're going to replace the virtual device connection string, the device of virtual device connection string, use it to replace that of the Raspberry Pi. So I'm selecting everything in the Raspberry Pi connection string, and then I've copied that of the virtual device. So I'm simply going to Control P. Then with that, I expect it to start sending telemetry to the hub. Meanwhile, it's sending right now. So let's view what's happening in the analysis points. So to do that, we simply just create the stream analytic environment and use it to analyze the data flow from this device. So I am going to open the stream analytics resource, stream analytics resource, stream cluster. Now we have two variants. We have the clusters and we have the jobs. The clusters are usually for critical cases, and they are quite it's kind of pricey. So we're using the jobs for the demo. The jobs cost us $0.12 per hour. So we are going to create a job, a stream analytical job. And let's call the job temp stream 123 dash job. Okay, now the same subscription resource group is temp data 123 resource group. The South Africa is selected. By default, I'm giving 3 streaming units, but we need 1. So I have chosen just 1 and I create this resource. Creates the resource. Remember, the resource has 3 components: the inputs, the query, and the outputs. So once it is deployed, we'll go on to see how we can use these components to access the data and also carry out functions in the data. So right now we are going to go to the inputs. Sorry. Resource. Yeah. So this helps the menu to load properly. So right now on the menu here, we have the job topology, which consists of the inputs, the functions, the query, and the output. So let's go to the inputs and create add stream inputs. It asks us what type of stream input, what's going to be the source of our stream inputs, and we'll say stream from IoT hub. And the alias is IoT hub. So let's check other entries. First, we have our subscription, which is correct, but the IoT hub is wrong. So the hub we're using is the temp data hub, yeah, temp hub 123. That's what we're using. Okay. So the access given to us is the IoT Hub owner. And with this access, you have more functionalities and more functions and access permissions than somebody that has just the device access. So right now, that's about it. To say save. Save. Okay. Successful. Okay, now let's look at the query. Okay, already we have select all from IoT Hub into your output. Okay, the output alias, we have to configure that also. Now, we are receiving the data right now. Yes, I can see Raspberry Pi data 77, humidity 77, our temperature is 26. So right now the data is coming in already. So what we need is the stream of data from our device. What we need to do is to save this query and go back to configure. You can refresh it to be sure that it is your stream data that is coming in. I'm refreshing it. Okay. Refreshing it shows me the contents flowing in. I have up to like 50 in. So test this query. Okay, let's do that. Will still help us to refresh the entire system. Okay, so that's from my Raspberry Pi. The data is flowing in. So let's configure our outputs. Let's configure our outputs. Okay, now let's add output. And what's going to be our output? A blob storage. Okay, the output is a blob storage. So what's the name of this output? I'm going to call it temp output 1, 2, 3. Actually want to use 1, 2, 3 as an identifier for every work I'm doing right now, because it's possible to get things mixed up and you just select the wrong let's say the wrong container, the wrong blob storage, and that will make your data not to run. Once you have that error, sincerely, you have your data in another file, you'll be running another container or another blob storage. So I'm trying to use 1, 2, 3 as to identify all newly created resources I'm using right here in this demo. Okay, so right now I'm going to just scroll down. It's important to be careful here because any error here means my blob will not be seen, my data will not be seen. So I'm going to carefully look at the subscription. It is correct. The storage account is correct. Yeah. And the container, I'm using existing, not a new one. I'm seeing temp container 1, 2, 3. It's also correct. Authentication has to be true. Connection string. Scroll down. Then I think that's it. Setting authentication to connection string. I can now save my storage. Okay. I can save the output. These are the outputs. So now I have outputs, testing outputs, successful connection tests. So go back to query. You see that the output has been loaded. My output has been loaded. So I have temp output 1, to 3, I have, that means select all from IoT into temp output 1 to 3. So, and my data is still streaming, is still on. So I can actually send a query to say where temperature. Okay, this will waste our time. I'll still do this using functions. So now the next thing to do is to go to overview and get the system running. Oh, I've not saved it, cancel and save the query. Saved settings. Good. So let's go to overview. It is created. Let's have it start. This initializes the system, start. Do that, repeat that, start. Okay, so it says starting. Okay, so once it starts, we can now visualize. Starting means that data or telemetry is now being forwarded from the hub to the storage that we just created. So we can view the content of the storage that we created to see, because right now we have not sent any query to it. We just want to see the content. So, and we expect the content to be temperature data and humidity data. Stream job successful. Okay. So streamed job successfully. So I'll still allow it run, because starting, it has to get to the next phase where it says running. And once it's running, I'll know my data is okay. I can now go to the output, which is the container, and see the contents that has been loaded up. So this really takes time, and trying to do this in 20, 30 minutes gets kind of difficult. Please, and I'm sorry that, it's just the procedure is lengthy, but the knowledge is worthwhile, because it helps us. You can connect your personal home network to the cloud. You can connect your home smart network yourself without requiring anyone to come do it for you, because allowing access to let's say the streets vendor or the streets admin person to come can also make your internet, your immediate network vulnerable, because if you don't have an idea of what they are doing, of course, physical access is the easiest way to gain access and carry out malicious activities in your network. So the knowledge can be placed under situational awareness, which is the trending direction of recent years. Situational awareness in IoT, situational awareness in security, situational awareness in various sectors, so that individuals can actually leverage the availability of these services, these resources, and be responsible for your immediate computing services, computing network, and so on. Okay. I know we have professionals here, but I also know that some will require such knowledge, not for commercialization, but for being able to, like, during the workshop, somebody said, my system has been slow, my system has been, I suspect it has malicious where on it, or has been attacked or something. So there are activities you can carry on yourself that will help safeguard your content, your data, your privacy. Okay, so no knowledge is wasted. So for instance, you can have, say, a student version of this application and create a storage account, save your documents, save your credentials, and there are many other ways to do that anyway. So, well, this is just one of the ways to have bigger storage allocation. So can we refresh this system? Taking forever. Okay, thank you. It's up and running. So now I would want to check if data has been streamed into my container. So to do that, let's go to the container and see for ourselves. Don't forget we have a storage account. So I'm going to simply look for my storage account. Storage account. Now the storage account is called store123. And then I'll check for the container in this storage account, which is temp container. Yeah, thank you. We have a blob in our container. So I'll double click on this blob, download the blob, and then open this blob. The blob opens in Visual VS Code. It opens in Visual Studio Code environment. So I'll have to like bring up a new share to view it. Sorry. So I'm just going to open this. Okay, it's bringing up my Visual Studio Code. And now it's up. So I'm going to do a new share for you to view what came up. Okay, let's say new share. My screen. Yeah, this is what I have. I have message ID is here. That's I have up to like 3 messages sent. And the ID is Raspberry Pi web client. The temperature readings are here. Humidity readings are also here. So we are going to carry out function testing, try to analyze this data to see how the content can help us better gain deep, better insight into the entire system. So permit me to go back to, okay. I hope my screen can be seen. Just to be sure. Okay, I hope so. Okay, now we've seen what data we have. So let's go and analyze, do further activities on this data by going through. Let's look for stream data, stream analytics. For the jobs, we have temp, okay, temp stream, 1, 2, 3. Let's go back there. Okay. So go back to overview and see if the system is still running. Yes. So long as the system is still running, we cannot run functions. So we have to stop the system, say okay, before the functions can open up. Stop again, say okay. Stop it. Thank you. So once it stops, we can now go back to use the functions. For the functions, we have to okay, let's finish this. This is, I don't know. That is why the Edge is better. If you run Edge, you will love it. What the Edge does is all these are on device. So the models are on the device and the speed is wonderful. So you see that the latency for sending cloud telemetry and I don't know, it's just heavy. So, but when it's on device, it's actually faster. Okay, but we are blessed to have all this. Stopped. Okay, so let's go to the functions. Job is still running. Okay, well, let's see. Stopped. Okay, can you now work? Let's check. Okay, now it's up. So let's create a function. Now, like I said earlier, we can create ML service function. So we can actually use machine learning to work on these. We can use machine learning service, machine learning studio, JavaScript UDA, JavaScript UDF. And in the UDF is what we're going to use as user-defined functions. So I'm going to just open my user-defined functions. And there are arguments here already, but I'm going to change that. After function name, I'll tell it to take up the parameter temperature. And then instead of returning the sum of the arguments, I'll tell it to use temperature. Sorry. And UDP. Now this gives you, sorry, permit me to get the exact function I intend to use on this. So, okay, so return, okay, when I return temperature greater than 25, and query this, if the temperature is greater than 25, return true, else return false. If temperature, let me look temperature, if it is greater than 25, return true. That's the question mark is querying it. Return true, else return false. This is done. So we are going to give the function a name. And the name, let's call it temp from 1 to 3, temperature 1, 2, 3. Okay, done. Then save this. Okay. All right, so let's go back to query to integrate our function. Instead of having select all, okay, we're going to now have what we have there as the temperature and user-defined function dot the function name temp function name 1, 2, 3, and then the function parameter temperature. Okay. Good. So let's test this query. Reference error temperature. Oh, sorry, spelling. Where are you? Okay. Reference is not defined. Not defined temperature. Think funk, sorry. Permit me to go check. Temp from 1 to 3. Excuse me. Temperature, UDP. Temp from 1 to 3. Temperature. Okay, so let me go back to my function. Okay. Can we save this first? Save. Good. Now let's go open the function. Yeah, see what we have a problem. Temperature. Let's save again. Okay, so back to query, and test. No data. Let's go stream. Okay, it's coming now. Yeah, we up and done. Thank you. This is interesting. I can spend days working here. I'm sorry for all the glitches. Still sending telemetry. Okay, so okay, done. So remember, I asked it to give me only when the temperature is above a threshold, let's say 25, return a Boolean value, which is 1, that's true. And when it is below that, return false, which is 0. So I think this is done. So we go back to overview and start the system. Start. So starting the system again, we'll send the new values into the blob storage. Repeat the stats. Starting, instead of wasting my time, I'll ask it to refresh. Okay, let's let it be. So I think this is it. And once it starts running, it sends the new data to the blob storage. We can also view it using our VS Code environment and call it a day. It's not fast and starting. Please do start. Okay, it's running. Oh, thank you. Now let's go view our blob storage and be sure content is flowing in. So permit me to go to home, storage accounts, storage accounts. This is my storage account. Then the container inside the storage account. We had just one blob before now, so let's see. We have 2 now. So looking at the, this is the first one. The one under is the second one. So let's double click this, download it, view the JSON file. Permit me to do a new share my screen. Okay, now it's returning true, false, true, true, true. I can actually stop and send that again to populate. Let's just see if that works. Stop, run. So let's hope it populates it better. So while it's working, I would like to go refresh my blog. This is my storage account. I want to refresh it because I just pushed more data in. Refreshed, then open this. Open the container. Now view this again. Let's see if there's increase in the amount of data that has been pushed. Download. And view. Let's open this. Yeah. Thank you. Thank you. Thank you. Thank you. So I have more data pushed into the system. Now I have it populated, and it's giving me every data that is above 25 as true, and those below 25 as false. So this can be used to actually get insight and set a parameter or a threshold that says, if a blood sugar is up to this threshold, return an alert. If this is this, let's, with that, you can actually make better decisions. Okay, this person's blood sugar gets, maybe when he's in the office, the blood pressure gets to this level, the blood sugar gets to this. What are the things that trigger the sugar? Okay, when you are away from home, you eat junk food, and as a result, this happens. So why don't we advise him, take your food from home and go to the office? There are little things that can actually be done from data that has been processed and from insights that has been gained from the data. Thank you. Permit me to stop sharing now. Yeah. I actually want to thank the organizers of this workshop, and I want to thank World Resource Management in particular, because I don't know, since I joined them, I've gained so much knowledge, and I'm no longer afraid. Before now, I would cower away from presentations, but now my confidence is improving, and I'm learning every day, and I'm poised. I'm ready to learn more, go to whatever level I have to go to gain knowledge, to impact knowledge, to share knowledge. Thank you so much for this great opportunity. Thank you. I'm grateful.